So yes, as you already said, we are a startup, operational not for very long. We're located in Offenburg in Germany, and our focus is on least cost renewable high temperature heat. We use ceramic particles as high temperature heat carrier and also as a storage material. Typically in a 2-tank storage configuration known from molten salt, and we have heat exchangers for different applications, for heat and for power applications. But we do not only do solar thermal, we also do electric particle heating, and as a backup, also fuel-based heating. So altogether, we can have a fully renewable, 24/7, fully available system. And with these 3 sources of renewable energy coming inside, we have a merit order. So we use the energy which is the cheapest. So if we have a typical plant, we're building our demo plant in the south of Italy, we first use the concentrated solar. South of Italy is DNI-wise not the best place in the world. So in winter, there's like 2 months without any direct insulation. But there are a lot of wind turbines in this area, which tend to overproduce at this period. So we can use this electricity to heat our particles. And then if there's no solar, no wind is available, we can still use fuel to provide the heat. We use ceramic particles because then they can go to very high temperatures. At the moment, we are at 1,000 degrees Celsius, but there's also potential to go further. And when we look at process heat for minerals, there are a lot of processes who need even much higher temperature. But from the conceptual view with ceramic particles, it is possible in the future to develop this technology further and go higher in temperature. Okay. So the first application here is renewable combined heat and power. That is not the subject of this forum, but important for us because it is our first demo plant. So where we produce steam from the hot particles and use the waste heat to provide low temperature process heat, but 24/7. You might ask why use 1,000 degree particles to produce steam at something like 600 degrees Celsius. It is just the cheapest option in our opinion. The storage gets cheaper with the higher temperatures, and also our steam generator, the driving temperature difference in the steam generator gets lower with the higher particles. So we can optimize our system, and for the moment the outcome is we should go to the maximum temperature of 1,000 degrees Celsius. But with the same system, just another heat exchanger, we can also provide high temperature heat to industrial processes and, for example, to preheat scrap for an electric arc furnace where we replace electricity. That is a very cost-efficient application. And in this system, everything is the same, except that as a steam generator, we have a hot gas generator. And the advantage with particles is that here we can have a direct contact heat exchanger. So there's no tubes needed, no plates, that can be very cheap. Our solar technology is a centrifugal particle receiver. I hope the video runs. So we insert the particles at the top of the receiver they get accelerated before they enter the absorber chamber at the same circumferential velocity, and then they stick to the inner part of the wall. And then with the rotational speed, we can control the time of the particles inside the cavity. So solar radiation is entering through the opening on the bottom and hits the inner walls, which are covered by particles. And then we control the speed of the receiver, and we always have these 1,000-degree particles coming out at the bottom. With DLR, there was a successful receiver demonstration. Prototype size is 2.5 megawatt, and 965 degrees Celsius were achieved at the solar tower in Jülich. And now in Jülich, there will be a permanent research platform for which we, HelioHeat, will deliver the receiver, and also another smaller test receiver. When we had a look at this electric heating option, we found that electric heaters for temperatures over 900 degrees C are very expensive, more than 300 euro per kilowatt, and have also high operational and maintenance costs due to oxidation and other issues. So we are developing now our own high temperature electric heater with a target of temperatures above 1,500 degrees C and cost below 100 euro per kilowatt. At the moment, I can't tell you more. I hope next HiTeMP Forum I will come up with more news here. But altogether, this power to heat options opens our technology to other part of the world, where there's not enough DNI, but cheap, especially wind energy, but also photovoltaics. Our business model is to deliver the core components of the technology, the particle receiver and the electric backup heater. And we also support plant developers with feasibility studies, project development, optimization of the complete plant and basic engineering. So we are partnering with others to deliver these plants. By this, we cannot focus on one plant, but we focus on our core competence to deliver these heaters. And by this, we can scale quicker than if we would just work on maybe one project, which we could handle ourselves. So very important, cost competitiveness. Our main assumptions here are that at a level of, if we deliver 1 gigawatt thermal of particle receivers per year, we can achieve with 50 euro per square meter heliostats. I think that is something Steve Shell from Heliogen will speak about after me. Then a 30 euro per kilowatt thermal receiver, that is our part. We think that is achievable, easily achievable. 8 euro per kilowatt hour storage cost with the particle, and a 30 euro per kilowatt heat exchanger. We can achieve at very good solar conditions. Here, right on the bottom, the red point, cost of, we can compete with 1 cent per kilowatt hour. So that is coal thermal heat price. And that is very exciting. In this price is, of this price is around 75% is around the heat costs. So like the heliostat, the receiver, the tower, the transport system. Around 20% is a storage cost, and around 5% is a heat integration cost. And that, depending on project, the heat integration costs can be different. In a brownfield plant, it might be much more expensive to integrate. So our market entrance, we have a demo project funded by the EU, where we will build one pre-commercial module with 2.5 megawatt integrated into a pasta manufacturing plant in south of Italy. And there we have the 24/7 operation with the electric heater and the fuel backup. And it is supposed to produce 7,000 tons of pasta per year, dried pasta, solar dried pasta. Our main partners here are Barilla, the world leader in pasta manufacturing. And we have EPC, with the companies KT and NextChem from the Merck Tecnimont group. And then we have other partners, DLR as a technology provider, Heliostats coming from Turkey, and we have a partner for every other component. And yeah, the plant should be up and running by end of next year. And for the first commercial plant, which would come up after this demo, we expect heat costs of between 20 and 35 euro per megawatt hour. That depends mainly on the financial cost, but we find that it is promising because Barilla at the moment is paying around 25 euro per megawatt hour for natural gas. So there's a chance to compete even with this low DNI. It is around 1,700 kilowatt hour per square meter and year. Our roadmap is now, we have the demo plant financed, we're building it, it should come up. And so we hope with a CSP direction, we will have our first large plant in about 2023. And by 2025, we would build many per year. And on the electric heater, this year, we want to show our prototype and then bring that into the market correspondingly. Good, thank you.